Hello and welcome to the GitOps with Terraform AWS and Spacelift course on morethancertified.com. In this course, you're going to use Terraform and Spacelift to deploy modular infrastructure to AWS. We'll start with a monolithic deployment and then convert it to modules. After that, we'll utilize OPA within Spacelift to create policies to secure our deployment. So let's take a little look at what we're going to cover in the course. In this course, we're going to utilize Terraform, GitHub, and Spacelift to automatically deploy a pre-built Terraform app as soon as we push it to our repository. This app will allow us to deploy an EC2 instance and everything needed for a developer to connect their VS Code environment to that EC2 instance. You'll then learn how to convert this deployment to modules, exploring the different strategies for communicating between the modules, and ensuring we maintain a small blast radius to prevent undesired consequences from modifying everything as one monolithic file. After that, we'll utilize Open Policy Agent to develop a security policy that will prevent developers from deploying EC2 instances that are not a T2 micro. This will help you learn how to manage the security policy of deployments where multiple developers have access, an absolutely crucial skill in today's remote workforce. All of this will provide the hands-on training needed to build your own robust applications and begin working within actual companies. So what are you waiting for? Sign up for the course today, and don't forget to Terraform apply yourself. Let's talk a little bit about what we're going to build in this course. Now, I know this looks like a lot for 2 hours, but a lot of this has already been done, and you're not going to code every single one of these files manually. So what we're going to do is build everything within VS Code. We're going to utilize code that we've actually built in a previous course if you've taken it, the Build a Dev Environment with Terraform and AWS course. Now, it's pretty straightforward. The way the course ended up was it started with everything as one monolithic file. Now, that's how we're going to start. Now, as we go through the course, we're going to break those files up into networking and compute modules. Now, before we do that, we'll actually set everything up within a repository. Everything will be done within VS Code. We'll then commit all of that code to a repository. And then Spacelift is going to deploy our infrastructure. Once we break everything into modules, it's going to be a lot cleaner and a lot more easy to manage. So what's going to happen is we'll start with that monolithic app, and then we'll break it up into networking and compute modules. We'll then send that to our GitHub repository from VS Code, our local machine. Then Spacelift is going to connect to that repository, and it's going to run workers. And these workers are Docker containers. And what they're going to do is use something called Open Policy Agent, like you see here. That's its little icon there, that cool little helmet. And that's going to ensure that our compute instances do not exceed a T2 micro. Once everything passes, a Terraform runner is going to take a hold of that and deploy our internet gateway, public route table, our developer node, public subnet, security group, VPC, everything we need to create a remote development environment that then will be able to be run from VS Code and connected directly to it. So that's a basic rundown of what everything's going to look like once we're done. Let's get started. In this quick lesson, we are going to set up the keys and permissions for the user we're going to use to deploy our Terraform resources. So let's start out right here in the AWS console, and let's go to IAM. Now, as you can see, I've recently visited, but just in case you haven't, you can just search right up here in the search bar. Let's click on that. And now let's click on Users. Now within users, you may see a lot more information here. I've actually hidden most of mine. Let's go ahead and create a new user. So we'll click on Add Users. And for the username, feel free to use whatever you'd like. I'm just going to call it VS Code. And now I'm going to choose Access Key Programmatic Access. We're not bothering with a password. This is not going to be a user that logs into the console. So go ahead and click that. And next, permissions. Now, as you can see, I've got a group of admins. You can, of course, create a new group, or you can just attach the policies directly. And I'm going to do that. Just click on Attach Existing Policies Directly, click on Administrator Access, and then click Next Tags. Now, feel free to tag it if you'd like to. I'm not going to bother. And Next Review, we've got right here our username, programmatic access, and administrator access. Go ahead and click on Create User. And right here, you'll see that you've got your access key ID and your secret access key. Go ahead and download that CSV. In this lesson, we're going to set up the repository we're going to use for the course. You should have already created a GitHub account. If you haven't, go ahead and set one up before you continue. So let's get started. All right, the first thing I'm going to do here in my GitHub account, set up to this little plus sign here and select New Repository. And I'm just going to call mine tf-spacelift. Feel free to call this whatever you'd like, but this way I know that this is the repository I've got connected to Spacelift. Now for the description, I'll just call it the GitOps with Terraform course or whatever you'd like to call it. And I'm going to make it a private repository. That way, if I accidentally upload any keys or anything, which hopefully does not ever happen, it will be secure. So once we've done that, go ahead and click on Create Repository. Perfect, so now you're greeted with all of these instructions here. We're not going to use them quite yet. So now what I want to do is create a token that I can use to commit to this repository. So go ahead and head up to your little avatar here, click on Settings. Let's go ahead and scroll down to the bottom to Developer Settings and Personal Access Tokens. Now, if you're using VS Code and you've already got VS Code connected to your GitHub account, you actually don't have to do this. But since we have users who are going to be on a variety of different systems, I'm going to utilize GitHub in the most universal way possible. So once again, if you've already connected to VS Code, this isn't necessary, but if you have not, let's go ahead and create that personal access token. So I'll click on Generate New Token, and I'll just call it tf-course-token, just like so. I'm going to leave this expiration date at 30 days. Feel free to choose whatever is best for you. It doesn't matter because as soon as you see this video, the token will absolutely be deleted. I would very much hate you to have access to my GitHub account. So I'm going to choose everything with the repo, which is what's most important. Of course, if you plan on using this token for anything else, you may want to add additional permissions. But for right now, I think the repo access is all that I need. So I'll go ahead and generate this token. I'm going to copy it. And then I'm just going to open a notepad document and paste it in there, just like so. And again, this token is essentially ephemeral, so it really doesn't matter where you save it. If you lose it on day one, you can always go and generate another one, which actually is the most secure way to do that. In this lesson, we're going to get Visual Studio Code all set up so that we can start deploying our Terraform resources. So let's get started. As you can see, I've already installed Visual Studio Code. It was a pretty straightforward process. I am on a Windows machine, but this of course will also work on a Mac or Linux. So go ahead and first things first, let's get the AWS extension installed. So click on the extensions icon here on the left, and then search for AWS. And once you've done that, we've got this AWS toolkit here. Go ahead and click Install. Looks like everything installed fine, so I'm going to go ahead and close this pane and close this tab. And then I'm going to click on this little AWS icon. As you can see, we've got Connect to AWS right here, but before we can do that, we need to get some credentials installed. So head up to View and Command Palette. Then as you can see, I've searched for this before, but if you need to get to it, you can type AWS and then start typing Create Credentials Profile, just like so. and then open that. And as you can see here, I've got a credentials profile called VS Code. If yours looks different, make sure that you get this looking the same if you want to follow along in the course exactly. But of course, if you don't or you're comfortable making simple modifications, you can name this whatever you'd like. But what we need to do is populate this AWS Access Key ID and secret access key. So go ahead and open your credentials file and paste this information in, just like so. All right, and once you've done that, go ahead and Control S to save this file. You should not have this white dot that was up here before, and close this tab. And then click on Connect to AWS. And you should see your profile right here. If not, you can obviously type profile, VS Code, if you need to, and just click on that. And default region of US East 1. I actually don't want that region. I'm going to use a different one, but whichever region you choose, you can choose that here. I'm just going to say no. And I'm going to add US West 2. That's the region I typically use in my courses because there's so much default stuff that goes on in US East 1. I just prefer to stick with US West 2, but this is totally up to you. So once you've done that, you can go ahead and minimize that. And then open the extensions panel again. Let's go ahead and add something that'll give us a little Terraform syntax highlighting. Let's go ahead and type in Terraform. And as you can see, there is an official Terraform extension here. It's rated 2.5. It is pretty buggy. It might be better now that you're watching this video. Feel free to choose this one if you'd like. But I'm actually going to use this one here. It's just got a higher rating and it's been pretty consistent for me. So I'm going to install this one, just like so. All right, and I'm going to close that tab and close my extensions. So now that we've got our extensions installed, let's go ahead and create our working directory. So I'm going to go ahead and click on Open Folder, and I'm just going to set mine up in the Documents directory. Feel free to set this up wherever you'd like, of course, just like so. And then I'm going to create a new directory. And I'm just going to call it Terraform, just like so. All right, and I'm going to open that and hit Select Folder, just like so. All right, so now we have a working directory. We've got our extensions installed. Everything is ready to start the course. In this lesson, we're going to clone our initial code, make a few modifications if necessary, and deploy it using Terraform to see what we will be deploying throughout this course. By the end of this course, we'll have the same result that we're going to see here, only the entire thing will be automated through Spacelift instead of through the terminal. So let's get started. All right, so here I am. I'm in my Terraform directory that we created before, and I'm going to go ahead and clone some code, and of course, this link will be available in the course documentation. So let's run a git clone, https, github.com/more-than-certified/tf-spacelift-initial.git. All right, I'm going to clear my screen there, and as we can see, we've got some code here. Now, if you took my previous Terraform Fundamentals course, this will look very, very familiar. If you haven't, no big deal. All right, so let's go ahead and rename this folder. I'm just going to remove the initial after it, just like so. And I'm going to change directory into it. Next, what I'm going to do is I'm going to open my providers.tf, just like so. And as you can see, we are referencing that VS Code profile that I created before in AWS credentials. If you need to make sure that that's there, of course, you can always cat that out. AWS/credentials, just like so. And there is my VS Code key there. All right, perfect. So that looks good. The next thing I want to do is I want to check my terraform.tf vars. Make sure that the OS you were using is selected here. Now that's either going to be Linux or Windows in this case. Now if you are using Mac, go ahead and select Linux. All right, and then finally, I'm going to open main.tf. And let's take a quick look at some of the things we're going to need to do here. Now, the most important thing that we need to take care of is we need to create our SSH key. As you can see here, mine is called mtckey.pub for the public key. And if you scroll down here to this provisioner, you'll see that mtc key is the name of the private key. So what we're going to do is deploy an EC2 instance. We're going to add its credentials to VS Code, which will allow us to remote into that instance from VS Code. So let's go ahead and, if you haven't already, make sure we create that key. So I'll run an SSH keygen -t RSA. And then within here, I'm just going to reference that location. Of course, I'm on Windows. Linux will look a little bit different. And we're going to name that mtc key. As you can see, it already exists, which is fine. I will overwrite it and just enter through the passphrase and clear my screen. So now if I take a look, we can see mtc key and mtckey.pub exists. Perfect. All right, so now that that's done, make sure that the remote SSH extension is installed. If you search for SSH, you will see remote-SSH. That is installed for me. Go ahead and install it as well. All right, so once that is done, we're actually finished with the housekeeping that needs to be completed. So let's go ahead and run Terraform init, which will initialize our directory. All right, perfect. Everything is successfully initialized. Then I'm going to run a Terraform plan just to make sure that we don't catch any issues. Everything looks good. As you can see, we've got 9 resources. We've got some VPC action. We've got security groups, and we also have an EC2 instance. So that's perfect. Feel free to peruse that, of course, if you'd like. And then let's run a Terraform apply-auto approve. Now, before you run this, do note this is all in the free tier, so you should be fine as long as your account, of course, is less than a year old. But again, I do invite you to go through the entire code base to make yourself feel a little bit comfortable and make sure there's nothing crazy being deployed, which I assure you there is not. All right, so I'm going to go ahead and apply this. Go ahead and pause the video, come on back whenever it is done applying for you, and we will check it out. All right, everything is deployed successfully. Looks like my local exec provisioner did exactly what it was supposed to do. We've got a dev IP here of 3586.120.133. Of course, yours will be different. So I'm going to open my command palette. That is Control-Shift-P, or just click here. And as you can see, Remote SSH is already up for me since I use it so much. I'm going to open that, scroll down to the bottom, and there is my IP. So I'm going to click on that. This is an Ubuntu instance, so I'm going to choose Linux here. And yes, I would like to continue. All right, and how cool is that? We are now logged into our Ubuntu instance, and we're able to open folders and use VS Code on our remote instance successfully. So that's really cool, and this is the code we're going to start with, and we will start using it with the rest of the course, and we'll probably make a lot of modifications. But for now, go ahead and close this terminal. Unless you'd like to play around a little bit more before you continue, then go ahead and run a Terraform destroy auto approve to clear everything out. In this lesson, we're going to commit our code to GitHub and trigger a Terraform apply within Spacelift. Now, we're going to hit a small snag at the end of this process, but we will resolve that in an upcoming lesson. So, let's get started. All right, so the first thing I want to do is create a gitignore file. And this is going to ensure that things like the Terraform directory here, which is loaded with the provider binaries, which we definitely don't need to upload to GitHub as they are far too large. and of course anything else that may not need to go to our repository, such as crash logs and things like that. So let's go ahead and create that new file, and this is going to be .gitignore. That dot, of course, meaning that it is a hidden file. And then what we're going to do is just head over to this gitignore template here, and I'm just going to copy it. And of course, this link will be provided in the resources. Head back over to my gitignore file and just paste that in. Now, we actually might be using our TF vars to populate some of our variables, so I'm not going to ignore those. But everything else that is here, we are going to ignore and not send to our repository. So I will go ahead and save that file and make sure it is in the proper directory. There we go. We definitely don't need it in the .terraform directory. Okay, perfect. It's in the upper level directory. So now that we've done that, let's make a few modifications to our code. Since this is going to be running within Spacelift, this provisioner is actually not going to work. Now, this is something we're going to investigate later, but go ahead and just comment that out. So now that we've done that, let's go ahead and move our SSH key into this directory so that it can be used to create the key pair within AWS. So let's go ahead and take a look at which keys were in here. And I've got mtckey.pub right there, so we need to move that into this directory. cp ssh mtckey.pub, just like so, and I'll just put a dot, which means this directory. Perfect. So now we have our public key there. And if you scroll up here, the reason why we are doing that is because of this key pair, which needs to reference mtckey.pub. So now that we've moved it to this directory, we can actually delete all of this and just reference the file directly. So I'll go ahead and save this, clear my screen right there. So now that we've done that, I'm just going to scroll up, make sure that there's nothing else that I need to do. Everything is looking pretty good to run within Spacelift. As you can see, the other file that we deal with is the userdata.tpl, which is already here, so that is perfect. Everything looks good. So now what we want to do is we want to go ahead and initialize Git within our system. So I'm just going to split the screen here. And with the other screen, we'll go ahead and utilize our repository. So that way we have our instructions here. All right, so now I'm going to follow these instructions here. I'm going to run a git init, just like so. And of course, we have a lot more files than just a readme, so we're going to do a git add and a dot there, which means the entire directory, of course, except for any files in the gitignore. And once I've done that, I'm going to run a git commit -m first commit, just like so. Perfect, everything is looking good. Then what we're going to do is create the main branch. Since master is somewhat deprecated and convention is to use the main branch now, we are going to follow convention. So git branch -M main. Once we've done that, let's go ahead and add our origin so it knows where to commit these files. Go ahead and paste that in just like so. And git push -u origin main. All right, everything worked well there. Now I have already authenticated to Git within VS Code. If you have not done that, it will ask you for your username and a token. As you remember, we created a token earlier. So what you want to do is just utilize that token that you created and paste that in, and that will allow you to push your code. All right, I'm going to refresh this, and there is all of our code there. Perfect. So now I'm going to maximize this, head over to my stacks here, and let's create a new stack. So I will choose that repository that we created, TF Spacelift, just like so, and branch is main. I'll go ahead and click continue. All of this looks good. Manage state, yes, that's what we want to do. So go ahead and continue that. We're not going to bother with any of these other options right now, but we will definitely take a look at them soon. Go ahead and click Continue. Stack name TF Spacelift is fine. And save stack. Perfect. So now let's go ahead and click on Trigger. And go ahead and wait for this to kick off. Again, there will be an error, so don't mind it whenever you see it. Go ahead and pause the video, come on back once it's done, and we'll see how it went. All right, here we are. Once again, as you can see, we have no credentials in the environment. This again is the problem I expected, error configuring Terraform AWS provider. Although Spacelift has other ways to deal with authentication, we're going to start with the simplest way and just provide the credentials as environment variables. So let's get started. So what I'm going to do, we're here in our stack. You can see our failed commit here. Just going to back up here and head to the environment tab. Now here, we're going to be able to add the credentials we need to add. So let's go ahead and do that. I'm going to open VS Code. And as you can see here, I'll just clear that and do this again. Let's go ahead and cat our .aws/credentials file here. And VS Code are the ones that I'm using. Now these other ones are stale and long gone, so please don't try to access any of my accounts with these tokens here. But let's go ahead and take a look. We've got VS Code right here. Let's go ahead and copy this AWS Access Key ID. I'm going to move this out of the way, and I'm just going to edit this environment. Let's go ahead and add a new environment variable, and we're going to call this AWS Access Key ID, just like so, and paste in that value. Now, after that, we just need to get a hold of our AWS secret access key. Go ahead and copy that, and then let's create a secret out of this and add our next one. And this, of course, is going to be AWS secret access key, just like so. And let's paste that in and define that as a secret as well. Now, as a secret, as you can see, you can edit, but you can't ever see it again. So make sure you still have it saved somewhere, or just be prepared to create a new one if you ever need this again. All right, I'm going to click on Done here. So now let's head back to our runs. As you can see, we have a failed run there. Let's give this another shot and hopefully everything works as planned. Let's go ahead and click on Trigger, and feel free to go ahead and pause the video while this is running. As long as everything works well, it should take a pretty good bit of time to finish the deployment. Once it's finished, come on back and we'll continue. All right, as you can see, everything is initialized, prepared, and queued. So now go ahead and click on the Confirm button once that is ready to go, and that will start deploying our infrastructure. All right, it looks like everything applied complete, and we have a dev IP here as one of our outputs. So let's go ahead and ensure that this works. So I'm going to copy that dev IP. Let's bring VS Code back over. Going to clear my screen here. And let's go ahead and see if we can log in. So I'm going to run SSH-I, and then let's access our private key, which is still in the SSH directory, MTC key. And this is Ubuntu as a username. Paste in that IP address and hit go. All right, looking good so far. All right, we are in the instance. Perfect. If I run a Docker version, Docker is installed. Okay, everything is good to go. But we still don't have the information we need to add it to our SSH configuration file, which allows VS Code to automatically connect to that instance. So let's go ahead and mark this lesson complete. Come on back to the next one, and we'll modify the output to allow us to very easily and seamlessly add the information we need to VS Code's configuration file so that we can connect using the SSH function as we did before. In this lesson, we're going to create a new output in order to output the script necessary to add our new instance to the VS Code SSH configuration file. Since we aren't running the provisioner on our local system, we're running it in Spacelift instead, we need an easier way to access this script necessary to add the connection information to that VS Code configuration file. So let's get started. Alright, so here we are back in VS Code. Now, if you take a look at the outputs that we have now, as you know, we just have the dev IP. We want a little bit more than that, so let's go ahead and create that. Let's create a new output. We'll call that connection script, just like so. Open and close some braces there, and that value is going to be template file once again. Now, here's exactly what we're doing. So if you go back over to our main.tf and look at our provisioner, as you can see, the command is basically just running this template file and utilizing the information within. So instead, what we can do is we can actually copy this. I'm just going to uncomment it by using Control/ there. And I'm going to copy this here, actually just this portion, and Control+C, then I'm going to recomment that. And then in outputs, I'm just going to head right here and paste that in. And instead of command, it's going to be value. So what we are doing then is we are now accessing the value of this template file with the host name, username, and identity file all substituted properly. As you remember, if we look in our SSH config script here, it needs to replace that host name, user, and identity file. So what will happen whenever it processes this output is it's going to replace those with the necessary items. Now there's only one thing we need to change here. As you can see, we don't have access to self anymore. Where here we had a provisioner within the EC2 instance, we had access to self. We do not have that within outputs. So what we're going to do is access that AWS EC2 instance. So we'll use AWS_instance dot dev_node dot public_IP. As you can remember here, AWS instance dev_node, and we just access the public IP of that. Now the user, of course, is Ubuntu, and the identity file is still located within the SSH directory. So we can go ahead and save this. And now let's go ahead and commit this to GitHub. So we'll just run a git add, git commit -m, added connection output, just like so, and git push -u origin main. All right, perfect. And if we head back over to our repository, I'll refresh to make sure it's all good there. We can take a look in our outputs and see our new output right here. Now I'm also going to just ensure that things went well. I should have done this already. Just run a Terraform FMT. Okay, cleaned up some spaces. That's perfectly fine, but everything else looks to be okay. So head back over. I'm going to back up. And as you can see, it's automatically picked up our new file and is planning to deploy. So now that it is planned, everything looks good. It looks like the plan was successful. Changes to outputs. Here it is, actually right here. Everything looks like it's working perfectly. So you can go ahead and confirm that, which isn't going to really do anything new except for add this new output. So give that a little bit. All right, apply complete. So now we have our connection script here, and it is all ready to go. So what you can do is just copy this here. You'll leave off that EOT here in EOT. We do not need that here doc syntax since we are running on PowerShell, or at least I am. So I'll go ahead and copy this and head back into VS Code, paste that in, hit enter. All right, no news is hopefully good news. Let's head up and open the command palette and SSH. As you can see, we have connect to host. Scroll down to the end, and there's our new host. So let's click on that And hopefully everything works out well. I'll select Linux. All right, perfect. It looks like everything worked exactly like we had hoped. If we run our Docker version, there we go. Docker is installed. Perfect. So now we have a way to access that script we used before, although it's not completely automated. It's still done within Spacelift, and we have access to that script to make things easier. Now you can also, if you head back to stacks, let's open our stack again, you can see the outputs here. Now the only issue is you've got these little /ns here that can actually cause a problem. PowerShell may not treat those right, so you may not be able to utilize this like you would hope. So it's actually just a little bit better to access it from within the stack here. All right, and of course, if you were using Linux, you should have seen the Linux version of this. This is all defined by what is set in your variables. So now, let's go through the Spacelift UI to get a little more familiar with it and see exactly what we've deployed. So I'm going to head over here to Resources. And as you can see, we've got a cool little list of the resources that we have deployed. Now, I've got two other stacks here. We've got the demo stack and TF Spacelift, which was actually the dev stack I was using to create this course. So I'm going to limit that by the stack itself. And then what I'm going to do is add a filter. And that filter is going to be stack and GitOps with Spacelift. So now we only have the stack that we want to look at. And as you can see, if you highlight here, you can actually see all of the resources that we have deployed. So if I go up to group by provider, for instance, we can see that everything is in the AWS provider, except for, of course, none. And then we also have the type. So here we can actually see all of our resources, and we can see we have two outputs. Now, if you click on any of these resources, you will see a lot of great information about it. You've got the address here, you've got the stack, resource type, and of course, all of this wonderful stuff from the API telling us exactly all of the attributes that we have set. Now, if we take a look at the output, this is super convenient usually. Now, the only issue, of course, is that these are URL encoded, so keep that in mind. We've got slashes there. And we've also got this U003C instead of the less than sign that we're supposed to have there. So it's still not as useful as the original display that we had directly from the run. So if I run back up here to stacks and click on my TF Spacelift stack here, and I will reopen the last run. And as you can see, the outputs are still a lot cleaner. So anyway, that's all we really need to see. I just wanted to show you that there is a way to see everything that's been deployed. And of course, you can go through logs and everything as well to see everything. Now we're going to optimize our deployment a bit by moving the public key to Spacelift instead of keeping it within our repository. Although a public key is perfectly fine to have exposed, it still might make your security team a little happier knowing it's in a more secure location rather than in your repository. Now, this can also allow your security team to rotate it more easily without having to deal with it being strewn about in multiple repos. So, let's get started. So what I'm going to do first is just double click on this mtc key.pub, and I'm just going to copy all of that and just Control C, just like so. And now I'm going to hop back into Spacelift. I'm going to press back here to get to the main stack area here and jump into the Environment tab. Now within that, I'm going to click Edit, and we're going to create a mounted file. Now you can just upload your file if you'd like. I'm just going to create one. And I'm just going to paste that content right in here, just like so. And then mount workspace mtc key.pub, just like so. And we can keep it as a plain text. That's perfectly fine. All right, all set. And if we preview it, we can see our key right here. So let's go ahead and close that preview. So now let's head back over to our code. Let's move this key. So I'm just going to type mv mtckey.pub and add a dot to move it up into another directory. You of course can delete it if you'd like, but I'm just going to keep it around just in case. All right, so now that we've done that, we need to make sure that we reference that. Now, as you saw, it's in mount workspace, so we need to reference that instead of just referencing it directly, because that is actually a different location than where the rest of our files are. So let's go ahead and find anywhere that is utilizing that. So I'll head into main.tf, and here is our mtckey.pub. So we'll just change that to mount workspace /mtckey.pub, just like so. I'm just going to do a little Control F to make sure that is it. 1, 2, yep, perfect. All set. All right, so I'm going to Control S to save that. And then what we need to do is just go ahead and commit this to our repository. So I'll go ahead and run that git add, git commit -m, moved, key, and referenced new location. We'll just say that. All right, perfect. Everything looks good. And now I will go ahead and run that git push -u origin main. All right, everything's been pushed. Let's head over to our stack. I will open the runs, and there is our moved key and reference new location. Let's go ahead and open that and give this a little bit. All right, so as you can see, nothing actually changed. Now we want to make sure we know for a fact that this works. So what I'm going to do is just destroy this entire stack and redeploy it, and let's see what happens. So I'm just going to press back here. I'm going to open tasks right here. And then we're just going to run Terraform destroy, auto approve, just like so, and let's perform that. All right, as you can see, everything is destroying. Go ahead and pause if you'd like and come on back once everything is destroyed and we will reapply. All right, that destruction took just a little bit of time to complete, about 3 minutes or so. So that looks good. And of course, you can add a comment or something here if you'd like. Let's go ahead and go back to our stack. And let's just trigger it again. And that should allow it to run and redeploy, and we'll make sure that everything works. So go ahead and click on trigger. And then of course, go ahead and pause the video once again. You'll get that little confirmation up here. Make sure you confirm. And then once everything is done, come on back and we will see what happened. All right, we've got an apply complete. So I'm going to go ahead and copy this information again so that we can add that to VS Code and ensure everything works. So I'll go ahead and clear the screen, paste that in and hit enter. Perfect. So now I will head up to my command palette, remote SSH. I'm going to roll all the way down, select this new node, and that is Linux. Continue, it's looking good so far. All right, beautiful. So now I will run docker version. And look at that, we've got our version good to go. Perfect. And if I just remove VS Code here and take a look, of course, that was the proper IP address and we are good to go. We have now moved our public key to Spacelift. So let's now take a look at defining our host variable in Spacelift. Now we could of course define it within the environment variables section where we have been defining everything else, but let's take a look at something called contexts instead. A context allows us to create separate definitions for our variables and assign them to different stacks. This will give us the ability to dynamically choose a set of variables depending on our use case, such as when we change operating systems or regions. So let's take a look. All right, I'm just going to close out this VS Code window here that is logged into our Ubuntu instance, since we don't really need that right now. And then what I'm going to do is open our terraform.tf-vars file here, and I'm just going to comment this out. You could also just delete it, doesn't really matter, but I'm going to comment it out. That way, the host OS is not referenced anymore. So now what I'm going to do is move this out of the way. And I'm going to head right down here to this little puzzle piece called contexts, and I'm going to open that. We're going to create a new context. So what we're going to do is call this a Linux dev context, which basically says, hi, if you're a Linux developer, this is where we're going to define any variables that you need. So I'll go ahead and add a description here, context for Linux devs, just like so, and create new context. So now I'm going to edit that, and I'm going to take this host OS variable, and we're going to define it here. And since we've been using Windows the whole time, I just want to show for a fact that it changes by defining it as Linux instead. Of course, since I'm in Windows, that won't work for me. If you are in Linux, go ahead and change it to Windows. So just do the opposite of whatever we were using. So the proper syntax here is going to be tf_var _host_os, and we'll define that as Linux, just like so. So basically what we've done is append this tf_var to our variable to indicate that it is a variable that Terraform needs to pick up. And we'll go ahead and set that as a plain text variable, which is perfectly fine. And save changes, and done, just like so. So now we have that set up. So now what I'm going to do is head back to our stack where we were. So I'll just go to stacks. So I'm just going to click manage next to my stack right there. And as you can see here, we've got a tab for contexts. So go ahead and click that. And let's attach the Linux dev context. And click attach. As you can see, you can change priority here, but since it's the only one, not really a big deal. So once we've done that, let's head back over to environment. And if you scroll down, you'll see attached contexts, and you've got that variable specified. Perfect. So now that we've done that, we need to repush to our repository because our terraform.tf-vars file in the repo still has host OS assigned, and that context is not going to override the terraform.tf-vars file, since the environment variables are the last variables to be analyzed. So let's go ahead and run a git add, git commit -m, commented out host OS, just like so, and git push -u origin main. All right, perfect. And I'll head back over. Let's take a look at our runs. As you can see, we've got a new run here. Now this should not do too much, but of course, go ahead and confirm when it asks. Pause the video, come on back once it is done. All right, perfect. Everything applied successfully. As you can see, 0 added, 0 changed, 0 destroyed, so it was very quick. But if you look at these outputs, guess what? We now have the Linux formatting instead of the Windows formatting. So that's exactly what we were looking for. So now let's head back over to contexts. Let's add a new context, and we'll call this Windows Dev, just like so. And context for Windows developers or whatever, and create new context. So now that we've done that, let's go ahead and edit an environment variable, and we're going to once again do tf_var _host OS, and we'll set this value to Windows. And once again, set this value to whatever the actual OS you're using is, whether it's Linux or Windows, whereas the other one was the opposite. And we'll go ahead and choose plain there, just like you can see. Save changes, and done, just like so. I'll head back here. So now that we've done that, let's head back into our stacks. Click on Manage once again. And for context, let's go ahead and select Windows Dev, attach that, and then let's detach the Linux Dev. You could also change the priority if you want, but I'm just going to detach it. Just like so, so now it is Windows Dev. So what we can do, we can either go and trigger, or we can make sure that we don't accidentally apply something else that may have been added, and all we need to do is just do a refresh only, which will affect only the outputs. So we can run a Terraform apply, auto approve, and refresh only, just like so, and run perform. And give this a little bit, come on back, and we'll see what happens. All right, perfect. As you can see, we are back to the Windows syntax. So everything worked just perfectly. We are now able to switch those contexts out depending on what type of operating system we're using. So we're all good to go. Now that we've had some experience with context, let's go ahead and add the region of our deployment to our context. Now this will allow us to change that region based on a developer's location, preferences, or whatever. Now we're going to keep everything in the same US West region for now, but in the future you can of course modify this the way you need it. So now there's one other thing I want to remind you and show you here. We are right now in a task view. As you can see, we've got the apply complete that we ran on this Terraform apply auto approve refresh only task that we ran. That is not going to show up in your runs view. So if we head back to our stacks, open TF Spacelift, as you can see, the last tracked run is here. And that's not the same run that we just ran. So do keep that in mind. If you run tasks, those will actually be out of this main view here. So anyway, now that we've covered that, let's go ahead and get to work. So first head over to contexts. And within each context, let's go ahead and add the variable for our region. So I'll go ahead and edit this Windows Dev here. Just click on edit here, and we'll just call this AWS_region, and the value is going to be US West 2. And we'll keep that plain text, that's fine. Save changes, and done. And then let's go ahead and do the same for the Linux dev context, in case you're using that. We'll go ahead and edit that. And AWS_var US West 2. Perfect. Save changes and done. All right, so now that we've done that, the context should already be attached. You don't have to detach and then reattach it or anything like that. So I'll just head back to my stacks and have that open for right now. Then I'm going to bring VS Code back over. And as you can see, I've got my providers.tf file open. So what I'm going to do is just delete this here and add var.aws_region, just like so, and save that. And then of course we need to initialize that variable within our variables.tf file. So I'll head to variables.tf, just like so. We'll add variable, AWS_region, type equals string. So now that we've done that, let's go ahead and see if all of this works. Going to clear my screen and run a git add, git commit-m added var for region, git push-u origin main. All right, all set. I'll move this out of the way. And we should see a new run here shortly. There it is, perfect. Go ahead and open that up. And whoops, as you can see, I made a little mistake here, got a little carried away, but it's very easily fixed. This is a mistake that's very easy to create. So it's kind of good that we got to see this. Head back over to contexts. Open up each of your contexts here. And do you remember the problem? You probably do. edit, and as you can see, I can't change the name of this. So what I've got to do is just delete it, which is perfectly fine. And we need to remember tf underscore var AWS region and US West 2, just like so. So if you ever get that error, make sure you appended this tf underscore var. This is something I do a lot, and I guarantee you're going to do it as well eventually. All right. So now that's done, let's head back over to our Linux and fix that real quick. Edit, we will delete this original one. Head back up here, tf var underscore AWS underscore region, US West 2, just like so. Save that and done. Perfect. So now let's head back to our stacks. And as you can see, we've got a failed run here. So let's just go ahead and trigger this again and see what happens. All right, things are looking a lot better. All right, as you might have expected, there was nothing to deploy. Everything worked perfectly. The region was set properly. So there was nothing that needed to be done, which is fantastic. So let's go ahead and let's destroy our infrastructure once again. So head back over to our tasks here. And as you can see, we have our Terraform destroy auto approve task ready to go. So go ahead and click perform again. And feel free to let that go, pause the video, and come on back whenever it is done. All right, the destroy was complete. So now let's just go over and take a look at our resources. As you can see, remember we were using the tf-spacelift stack. That doesn't even show up here because there are 0 resources. So that's good. So everything is clear. We shouldn't have any surprise bills or anything like that. If we take a look over here at the runs pane, you can actually see all of the runs that have been done, which user did it. There's a lot of really cool stuff here also to take a look at. But that is all for this lesson. Come on back to the next one and let's continue the course. Let's step back from our deployments for a little bit and let's talk a little bit about how Terraform modules work. Now in the next few lessons, we're going to be refactoring our application to modules from what we have now, which is a monolithic deployment. And we're going to be moving a lot of files around and creating a lot of information. So it's going to really help to understand how those variables, outputs, and everything else flows through these modules to make them work properly. So let's take a look. So first, we set our variable host OS as Linux. And of course, this is done in our Spacelift variable context, but could also be done as an environment variable within terraform.tf vars, or as a default within variables.tf, wherever we'd like. Now after that, we initialize that variable, and of course, we set a type here. If this is not a string, then this will fail the deployment. Now after that, we set up our main.tf within the root module. Now this is essentially, as I said, what we've been doing all along. But instead of defining resources, we're going to define modules. So we define our compute module and our networking module, and you would name these whatever you want. And if you want to deploy multiple computes, you can, or multiple networking, you can. Now, as you can see, the source references the directory in which those resources are stored. And then what we do is we pass in this variable, hostos, var.hostos. So hostos now equals Linux for the compute module. So we're essentially setting the variable definition here instead of, say, a terraform.tf vars file. Now, as you can see, we also have subnet ID here, but I will discuss that very soon. So after that, we want to deploy our networking resources. As you can see, we can deploy a VPC, and then of course these 3 dots indicating that we have a lot more to deploy, especially a subnet, for instance. After that, what happens is we need this subnet ID to be usable by our compute module. So what we do is we actually output that subnet ID through our outputs.tf, and of course you could do it from main.tf if you want, but to break things up, we'll be using outputs.tf, and we're going to send that value over to our main.tf so that it can be used by our compute module. Now, as you can see, we don't reference it the same anymore. We reference it by the module from which the information comes. So module.networking.subnet-id. Now, one very important thing, as you can see, module.networking.subnet_id, that's because we can only access output names. We cannot output any attributes that are not exported here. So since we're only exporting the .id here, that's all we have access to and that's all we need. So that's great. So once we have that, we can then deploy the compute module because we have everything we need, the host OS and the subnet ID. So next we pass that host OS and that subnet ID in using the variables.tf file, which basically, as I've mentioned before, initializes these variables and sets their type if need be. Then after that, that can be consumed by the main.tf, which we may actually call compute.tf to help avoid confusion as we start opening all of these files. So essentially, resource AWS instance dev node subnet ID equals var.subnet_id. So it's accessing this variable here. So as you can see, this variable, which is right here, if you follow it all the way back, is actually this value, AWS subnet.mtc_public_subnet.id. So you follow it through, that's how we access that subnet. Now, this whole process is very useful. If this is difficult in the beginning, it is very beneficial to just draw things out. So after that, we need to still use our host OS, which is actually found in our output. So the output of our connection script is actually a template file, and that template file needs the host OS to determine which SSH config file to use. So in this case, it would be linux-ssh-config.tpl. And as you can see, we have our host name and user and everything else, but that's all passed in from our main.tf. So after that, we then utilize that linux ssh config.tpl and replace it with the correct values. As you can see, we would replace it with a host name that came from our deployment, user, identity file, and everything else. After that, we need to send that to our outputs. Now, this is the root module output. So essentially what's happening is we have the output here, output connection script. So we need to access that from the root module so that we can see it on our main output. We're not going to see this module's output. That's all hidden. But from the root module, we will. So the value is simply module.compute.connection script. And that's it. So that makes things a lot easier and more secure because we don't have access to all of these outputs, some of which could be very sensitive. We only have access to the outputs that are output. So once we've done that, it then outputs this wonderful little script that we can copy and paste in our VS Code to add this host to our SSH config file. And then we connect that host to our EC2 instance and everything should work perfectly. So that's basically how it all works. As you can see, you can follow these arrows. Feel free, of course, to download these slides. I will provide them, but hopefully that helps throughout these next lessons to help you understand how everything works. Feel free to reach out if you have any further questions. Go ahead and mark this lesson complete. Come on back to the next one and let's continue the course. Hello and welcome back. Now that we've seen how to deploy a monolithic Terraform app through GitHub with Spacelift, let's create some modules to make this deployment a little more flexible. This will allow us to easily spin up extra development instances without having to touch or even allow access to the underlying infrastructure such as the VPC, subnets, security groups, etc. So let's get started. So what we're going to do is we're going to split up our infrastructure resources, such as the VPC, subnet, internet gateway, etc., and the compute resources, such as the key pair and the instance. So what I'm going to do first is just create 2 folders for those. So let's go ahead and create a new folder. And I'm actually just going to call one of them networking. And I'll call the other one compute, just like so. So now within the networking folder, I'm going to create a networking TF, networking.tf, just like so. And the reason I'm calling it networking.tf instead of main.tf is honestly just so we don't get lost while moving between all of these folders and files. Now we will want to rename this to main.tf to follow standard convention, but for right now, it'll make this entire lesson a little easier to follow. So let's go ahead and get the networking resources into this file here. So I'm just going to scroll up to the top and just grab everything down to the key pair, just like so. Going to Control X that and save and paste that into here and save, just like so. So now that I've done that, let's go back to our main.tf and let's just highlight everything else here. Cut that out. I'll save that file so I remember. And in compute, I'm just going to create a new file, compute.tf, just like so, and paste that in and save. All right, so the next thing we have to think about is within this compute file, how are we supposed to get to our subnet ID and security group IDs? Since these are two different modules, they actually are unable to just communicate with each other outright. We actually have to do a little bit of legwork to ensure that both of these can communicate. So what I want to do is I want to output those values that we need from the networking.tf file, and then we're going to end up inputting them as variables into the compute.tf file. So what I want to do first is create a new file, outputs.tf, within our networking directory here. And what I want to do is create two outputs. So output security group ID, just like so. Open and close some brackets there. And what we want is we want the AWS security group mtcsg.id. So if you look over here in the networking file, we can scroll down to the security group. And as you can see, AWS security group mtcsg, and we need that ID. You can also find that here in compute.tf. As you can see, now also notice that it is in brackets here. Now we're not going to use these brackets in our outputs. We're going to use those brackets in another place. But right now, this is what we need. So what we can do is we can actually copy this, Control C, and head back over to our outputs and set that value equal to that, just like so. Now, if you know you're going to need multiple different outputs, you can also remove this ID, which will give you access to the entire security group object. But if you know for a fact all you need is the ID anywhere else, it's a good practice to make sure that that's all you export, because anything you export is accessible from other modules, and that may not be something you want to have accessible. So go ahead and save that, and now let's work on the subnet ID output. So we'll say output subnet ID, just like so. Value equals, and if I head back over to compute here, we can see that we need this value, AWS subnet, MTC public subnet.id. And we are going to change these soon, but we're just not going to do it yet. So go ahead and paste that in, and that is everything we need for the outputs. So now everything in networking for right now is good. We don't have any variables we need to address or anything like that. So let's go ahead and head over to compute and start to get that ready. So now over here in compute, we need to make sure it has access to everything that it needs to access. For instance, we've got userdata.tpl, and we've also got a data source here. Now, right now, our data sources.tf are outside of that directory. So let's go ahead and move data sources.tf right here into the compute directory, just like so. So now that has access to our data sources, and we don't need to do anything else. Perfect. And then what I want to do on top of that is just go ahead here, this VPC security group ID, and I want to change that to var.security group ID, just like so. We haven't created this variable yet, but we're going to. So our subnet ID is going to be var .subnet ID. Just like that. So the next thing I want to do is I want to move this user data file here into the compute directory. And then to reference that properly, and to ensure we never have a problem referencing it, what I'm going to do is use my interpolation syntax. And we're going to say path.module/userdata.tpl. So what that does is ensure that we're accessing the path of the module to get to userdata.tpl. All right. And we're getting close to finishing up here. The next thing we need to do is we need a variables.tf file. New file, variables.tf, of course. And then what I need to do is create the variables that we did here, security group ID and subnet ID. So let's go ahead and do that. Variable, subnet ID, and that type is going to equal a list. Remember, it's in those brackets. And then we have a variable, security group ID. And that type is going to be a string, just like so. So now we have variables set up. We've got everything here replaced within our compute. The one more thing we need to do is we need to add the outputs for compute. So if we go down to outputs.tf, this is actually all fine, so we'll just drag that into the compute module here, and we are all set and ready to go for our two modules. So the next thing we need to do is actually write our main.tf that's going to reference those modules. Now I know we just did a lot of refactoring, but we're about to create the root module that is going to bring all of this together. Now that we have our compute and networking modules, we need to create that root module that is going to basically deploy resources from our other modules and allow us to pass data between them. Data such as our subnet ID and security group IDs. So let's get started. So the first thing I'm going to do here is just open up my root main.tf right here, just like so. And what we want to do is we want to reference our two modules. So first up, I'll reference my networking module. So we're going to use the module keyword just like so. Instead of using resource, we're referencing a module. And that's going to be networking. And under that, our source is going to equal ./networking. So basically, we are just referencing our networking module. Now, there's not a lot we have to do with networking since we haven't specified any variables. Now, of course, if you'd like to go and create a lot of variables to make it a lot more flexible, absolutely do that. But that would take a lot of extra time from this course, and we're just going to kind of stay on topic here. So next up, let's do our compute module. So module, compute, open and close those braces. And our source is going to be, you guessed it, ./compute. And then what we need to do is we need to pass in that security group ID and that subnet ID. So this root module is able to access the outputs of our networking module. And it accesses them by the name of the output. It cannot access this directly. What it can access is whatever value this output contains. So what we're going to do for this, we'll start off with the security group ID, just like so. And again, that is named after the variable that we use within our compute module. So if you look in our variables, security group ID, just like so. So this here, this variable, is going to look for its definition from this root module. And then this root module is going to define this security group ID based on the output of our networking module. So what we'll do is, and remember, this has to be a list. This is passed in as a list, so you can pass in multiple security groups if you'd like. But in this case, we only have one. So we're going to access it by typing in module.networking.security group ID, just like so. Now for the subnet ID, it's going to be very similar. That's going to be module.networking.subnet ID. And again, this is the output name, which you found right here in our networking output, subnet ID. which then equals AWS subnet.mtcpublic subnet.id. So now the last thing that we need to pass in is the host OS. Now, remember, this is a module here, and our variable is not going to be able to be passed into this compute module from outside of it, from the context where we defined our host OS. It's going to need to come through the root module first, and then into our compute module. So the host OS is going to be var.hostos, just like so. So if we go back to our variables.tf, we can actually remove this default now because we have that context supplying that. So we have our variable here, which will be defined from Spacelift, where it's defined, and then it's going to run into our main here, and then it's going to be passed into compute. So to get it into the compute module, we're also going to need to add this host OS to our variables file within our compute module. So let's go ahead and do that. Variable host OS type equals string. And then what that's going to do is now allow our outputs.tf within compute to access that host OS that we need, that variable. So to work it backwards, var.hostos here in our outputs.tf within our compute module is then initialized by the variables tf file within our compute module right here, which is then defined within main.tf right here, which then references the var.hostos within its own variables.tf file right here in the root, which is then defined from Spacelift. I know that's kind of a lot, but it'll start to make sense as you practice. So now that we've done that, I'm back over here on my main TF within the root. Let's go ahead and check our variables here once again, make sure we have everything. Host OS and region, that should be everything that we need. So one last thing we need to do here in the root is we need to access that connection script from our outputs within our compute module. So we have our output connection script right here. So all we need to do is access that and redisplay it. And if we'd like, we can also do the dev IP. So if I head back to my root, and I'm going to minimize this here, and within the root, if I create a new file, outputs.tf, just like so, we can then create our output. Output. Let's just do the connection script. There's no real reason to have that dev IP there as well. So our output connection script, we're just going to say that value equals module.compute.connection script. And that's it. So now our output from the root is going to be able to access the compute module right here and pull that output of the connection script, which you see right here. So that should be pretty much everything we need to do to launch this. I'm sure there's something I missed somewhere, but hopefully I didn't. Let's go ahead and run a Terraform fmt-recursive and just clean everything up a little bit. My spacing wasn't perfect. Everything looks super clean. And that's perfect. We have now completed a lot of refactoring, and we've completely modularized our deployment. So let's push this thing to GitHub and see if it hits any snags on our first deployment. So I'll go ahead and run git add, git commit -m first modules. And then, as you can see, we've got a lot of stuff going on here, which is expected. And then what we'll do is run a git push -u origin main. All right, everything is pushed. Let's head over and see what's going on. Looks like something is running. As you can see, I had a lot of experimental builds. You can please ignore all that red. Hopefully you don't have nearly as much as I do. Let's open this up. Aha, as you can see, our type checking actually worked here. So it's expecting a string for the security group ID. Let's run back over and see what I screwed up. So if I head into variables.tf, I got this backwards. Whoops. So this is a string, and this is a list. So now you can see exactly what happens if you screw up these type checks, which is great. That's something that is very good for Terraform to be able to do, and I'm glad it caught it. So now let's run git add, git commit -m fixed stupid mistake, git push -u origin main. All right, let's try this again and see what happens. And we're queued. Perfect. So go ahead and pause the video, come on back once it is ready, and we will confirm this deploy and see what happens. All right, the plan looks good. Everything looks exactly the way it should as far as I can tell. So let's go ahead. We've got 9 resources, which we're very used to seeing. Same number of resources. We're just using different modules this time. So go ahead and click confirm. And once again, pause the video, come on back whenever it's done, and we will continue. All right, our apply is complete. So first of all, let's just test to see if it works. So I'm going to grab this connection script here. Of course, if you have been using Linux, yours looks a little bit different than mine. Going to clear this and paste that in just like so. And I'll hit this command palette, connect to host, and scroll all the way down here. That IP address matches. Let's click that. And it is Linux. I would love to continue. And beautiful, everything still works. So I'm going to just close that now. Let's move this out of the way and let's go take a look at some of our resources. I'll head back to my main page of my stack and click on resources here. And as you can see, we've got our 2 modules. We have everything that we'd expect in our networking module, and we have the 2 resources we expect in the compute module. So that's great. If you'd like to filter, of course, by that, you can filter by lots of different things here, such as parent. We have module.networking right there, just like so. So you can filter by all sorts of great things and play around with those resources. And you can also, of course, click on any of the resources and see the types of outputs you've got and everything else. Here's our output there. All right, so that's perfect. So everything worked exactly the way we had hoped. Now that we've deployed our first modules, we can now explore the real power of modules and see how we can deploy another developer workstation by just simply adding another module with a different variable set. So let's get started. Now the first thing I'm going to do, since we're going to be breaking a lot of stuff and changing a lot of things, is I'm going to just go ahead and nuke this stack. So I'm going to head to my tasks once again and just run this Terraform destroy auto approve. So as always, go ahead and pause the video, confirm when asked, and come on back once it's done. All right, everything is all complete and destroyed. If I press back and click on resources, nothing to show. So perfect. So I'm going to head back into VS Code. And let's go ahead and start making the necessary changes we need to make so that we can deploy a second module here. Now we want it to be a little more flexible than it already is, so we're going to add a few more variables. So first let's head into compute.tf right here, and I'm going to create a variable for key name. So let's just go ahead and say var.key_name. And then for instance type, we'll say var.instance type. Now keep in mind, if you want to stay in the free tier, T2 micro is all you want to deploy. We won't be deploying anything more than that, but just keep that in mind since we are starting to change things that could cost you money. And then down here on the tags, let's go ahead and make this a little more dynamic. And we'll use our interpolation syntax here. We'll just say var.node name -dev-node. So If the node name is Derek, it will be derek-dev-node. All right, so now we need to create all of these variables within our variables.tf for our compute here. So, opening that up, we've already got our subnet ID, our security group ID, host OS, and now we need to add our variable for node name. That's going to be a string. Then we'll add a variable for key name, which is also going to be a string. And finally, we will add a variable for instance type. And then once again, you guessed it, that's going to be a string. Okay, so now we have the variables initialized within our compute module. So now let's head over to our main.tf in the root once again. And let's go ahead and define those. So what we want here is we want a node name. And I'm just going to say this one will be the main dev node. That sounds fine. Then we need to provide a key name. And that's going to be main key. We need to provide an instance type. And that's going to be a t2.micro. All right, perfect. And now what we want to do is we want to reference this module again to create another compute instance. So to do that, going to reference a module, and we need to name this something different. So we can name this Derek Dev. We'll just say that. It's Derek Dev's machine. So then we'll open and close those braces. The source is once again going to be compute, just like so. And then under that, we just need the rest of this. So I'm just going to copy it and paste it down here, just like so. Perfect. So the host OS can stay the same, or we can even change it. If you'd like, you can change that to Linux, whereas the other one was Windows, and it should override here. You can also, of course, utilize contexts and things like that, but in this case, this will be the easiest way to do it. Node name is going to be Derek, so it'll be Derek Dev Node. Key name, we'll say Derek Key, and again, feel free to use your own name or your dog's name or whatever you'd like. Instance type, we're going to keep at t2.micro. Now there's one more thing we need to make sure we do, and that's add the output for this module. So head into outputs.tf, and what we're going to do is just give this a different name. So the output could be Derek connection script, just like so. Open and close those braces, value equals module.derekdev.connection script. All right, once you've done that, let's go ahead and run a Terraform fmt-recursive. All right, and that cleans things up for us. So I think I got everything right. It looks like everything is good here. We have all of the same stuff. It's using the same networking security groups and subnet IDs, but we're using a different host OS. We've got the node name of Derek, a key name of Derek Key, and an instance type of t2.micro. So let's go ahead and git add, git commit-m, added Derek node, and git push -u origin main. All right, here's hoping, fingers crossed. As always, feel free to pause the video and come on back whenever you are ready. All right, excellent. As you can see, we have 11 to add now because we've added a new key and a new compute instance. So that is a very good sign. A lot of green pluses there. So let's go ahead and confirm and continue. Once again, feel free to pause and come on back whenever it's finished. All right, everything is good to go. And if we take a look at our two outputs here, as you can see, we've got a Windows output and we've got a Linux output. So the Derek connection script here is perfect for Linux. And the original main connection script is for Windows. So everything worked exactly the way we had hoped. If we head back and take a look at our resources, It looks like everything is good to go. We've got our Derek Dev, our main compute, and our networking stack there. All right, perfect. So everything looks good. Now let's step away from our stack for a bit to start learning a new concept to ensure that our developers don't manage to launch the largest possible EC2 instance just so they can run their JavaScript project a little bit faster. Now you can definitely use all sorts of little tricks with Terraform, such as variable validation, to control what gets deployed. But then you have to get very granular with permissions over the code itself. By using Open Policy Agent, which integrates with Spacelift, we can control these types of things outside of the code itself by using a different type of code to analyze the Terraform plan and validate if it meets our security and procedural requirements. So let's get started. All right, so here we are again. As you remember, we've deployed a lot of resources here. We've got 2 modules of compute, and we've got a module for networking. Now what we're going to do is kind of step aside and head over to our policies. And as you can see, there are some default policies. Now, if you head over to the docs, you can see we've got a lot of information on these policies. You've got login, access approval, initialization plan, etc., etc. Now, some of these are only available in the paid and enterprise tiers. However, the plan policy is available on the free tier, which is great. So we head back over, you can see that here. Login, access, push, and trigger are not evaluated for free accounts, but plan is, which is great because we're going to be analyzing our plans. So let's go ahead and add a policy and just see how this works. So I'll head to add policy, and we're just going to call this instance type policy. Now keep in mind, it's not going to do anything with instance type to start, but we will get to it. Now as far as the type, as you can see, we have a lot of different policies here. We're going to choose plan. And then what I'm going to do, feel free to read through this if you'd like, but I'm just going to delete all of the things, just like so. And we're going to start out with a very, very simple policy. We're just going to deny. And then we're going to add a message for this. And we're just going to say that message is denied. Open and close some braces here. And then within this, we're just going to say false. Just like so. So what we're saying is, if this is true, give us a message that says denied. Now, if it's false, whatever this evaluates to be, which of course right now is very obviously false, don't display anything. Now this is in kind of a scripting language, which is very similar to Go, called Rego. We're not going to dive too deep into it, but I will be kind of giving you some tips as we go to write some very simple policies, and I will provide documentation that you can use to dive deeper. So now that we've done this, let's go ahead and create this policy. So now we have a plan policy. Let's head back over to our stacks, TF Spacelift, settings, and policies, and let's attach this policy, instance type policy, and attach, just like so. So now what I'm going to do is head back over to my runs, and I'm just going to trigger a run. All right, give this a little bit to initialize, and once it's finished, come on back and we'll take a look. All right, as you can see, no changes have been made, and here our instance type policy is allowed, because we said the deny was false. Do not deny this policy. So perfect. Let's go ahead and see what happens if we set that to true. So I'm just going to center click here to open a new tab so we don't have to keep doing that back and forth. I'm going to open my instance type policy, edit that, and let's just say true right here and save changes. Now you don't have to reattach or refresh or do anything else. It's all done automatically. I'll head back over, press back, and trigger once again. So once again, pause, come on back once it's done, and we'll take a look at what we did. All right, as you can see, it was denied, just as we expected. Deny equals true. So that's great. Now do keep in mind that you can only use deny policies with a plan policy. You cannot use allow, only deny or warn. So that's perfectly fine. Just do keep that in mind. It will not evaluate an allow policy. So we head back, and as you can see, failing the run as per planned policy, denied by policy, denied. All right, so obviously that was a little contrived just to show you how it works overall. We have now seen the basics of how an OPA policy works. Let's now create something that benefits us. What we want to do is ensure that the developers creating instances cannot deploy an instance that isn't a T2 micro. So let's get started. The first thing I'm going to do is head back to my instance type policy. And of course, to get there, you can click on policies and select your instance type policy. And once we're in here, we can select edit. And what we want to do is just add one little thing here at the bottom, sample. And within some braces here, just type in true. So what this is going to allow us to do is sample this policy and test it out with our actual infrastructure. And you'll see what I mean here in just a second. Go ahead and save changes. Let's head back over to our stack here. I left it on failed. If you didn't, you can trigger it again. Actually, I'll just back up and let's just hit trigger. And of course, it is going to fail again. We haven't changed anything that should make it pass, but we're going to have a little more flexibility to test things out. Let's go ahead and pause while it's doing this. Come on back when it's done. All right, all set. As you can see, once again, it has been denied. Now over here, you see this show sample. Go ahead and click that. And now you can actually see this giant object here, which is what our policy was evaluating. Now, as you can see, we've got several items there. We've got information from a previous run. We've got created at. All sorts of information here. Now, if you keep scrolling down, you'll actually see at somewhere around line 115 or so, the beginning of a Terraform object. Now, this actually contains everything that gets changed. And you can see all of the information that gets changed, added, deleted, whatever. And there's a lot there to dig through. So what we want to do is we actually want to find where the instance type is selected and use that to evaluate whether the instance type we have chosen is correct or not. So here, let's take a look. So we just saw that giant Terraform object at around line 115. Now after that, you see resource changes. Then under that, you see change. So what we want is there are addresses here. And each address, of course, corresponds to a different resource. Now, there's a lot of information on some of these, so you may have to scroll down a lot to see all of them. And then here's another address here, as you can see. So what we want is we want every one of these addresses, and we want to evaluate the change under every single one of those. And then we want the after object here. And then after that, we can actually scroll down a little bit more and you get to the instance type. Now, as you can see, that's not a type we expect, but we're going to cover that here shortly. So what we want to do is check the instance type and make sure that it is a T2 micro. So what I can do is I can take those objects that I pointed out, which starts out with input, which is here. This is all the input. So we're going to set a resource variable, just like so, using this cool little walrus operator. And that's going to equal input.terraform.resource changes. And then what we can do is within these brackets, we can actually add a little underscore. And this basically says that every node under resource changes needs to be evaluated. So what is happening here is each resource is a resource that is found under resource changes. So after that, let's go ahead and find the instance type. So I'll just call it instance to keep it a little simple. Another walrus operator. And we're going to start with resource. Now I could just put all of this in one line, but this is just going to be a little bit faster and look a little cleaner. So we're going to take the resource that we used here, dot change, dot after. Remember, that's what the next objects were. So we have resource changes dot change dot after dot instance type, just like so. Now, if we want to see our first instance type, we can actually roll up to somewhere around line 148, if I remember correctly. There it is, instance type. Since both are T2 micros, they have the same item here. Now, this is a sanitized version of T2 micro. Any of our outputs here, or any of the attributes, are marked as sensitive within Spacelift. Now, there's a function to take care of this, but right now, just know that. So now that we've got that, we're actually accessing the instance type now. What we want to do is ensure that that instance type is a T2 micro. So what I can say is instance. And then remember, since we're denying, we are looking for a false statement here. If this statement is true, then it will deny. So we want a false statement. So we want to say, if the instance does not equal t2.micro, then it will fail. So what I'm going to do here is go ahead and simulate. And you probably know what might happen here. It's denied. And that's because our input right now is sanitized. But what I can do is just go ahead and type t2.micro here. Simulate again. Still denied. But let's take a look at that. So what I can do is just use some string replacement here. We'll just say $$Q. And after that, we'll add another little array here of items that will replace that Q. And that's going to be resource.address. So remember, we got our resource, which ends up at resource changes. And then we just want the address, so we'll know which one was the problem. So then I wrap all of this in sprintf, just like so, and hit simulate. So as you can see, now Derek Dev is denied. So if I head to Derek Dev and change that to a T2 micro, hopefully we get a different result. And as you remember, that was a good ways down. Here it is right here. So if I change the instance type to t2.micro now, hit simulate, no deny, everything worked. If I change this to a T2 large and hit simulate, Derek Dev is once again denied. So as you can see, it basically runs a loop over all of the instances and checks whether they are approved or denied. All right, so that's great. We see exactly how that works. Go ahead and mark this lesson complete. Come on back to the next one and let's fix this so that we're not dealing with T2 micro here. We're actually dealing with what we're supposed to. And this will evaluate without us having to manually change the code. Okay, we've now seen how to simulate our policies from the Spacelift console. So now let's see how to get our policy ready for action by adding a few more things. All right, so first of all, as you can remember, we were dealing with a T2 large here, but before, that looked a little bit different. Let's hit this reset button. And as you can see, this is actually t2.micro encoded. Now this is the way Spacelift sanitizes our outputs so that nobody can just peek in and see how everything is set, but that's perfectly fine. What we can do with our policy is utilize a built-in Spacelift function called sanitized, just like so, and like any function, you just wrap these in parents. So now if I click on simulate, nothing gets denied. It works perfectly. So excellent. So this policy appears to work perfectly fine. We have the resource address. It tells you which one was denied. We can even add a little bit more here. Due to instance type restriction, please choose t2.micro if we want to be very explicit. Just like so. If I hit simulate, still works, but if I throw a bunch of gobbledygook there and hit simulate, there you go. Module.derecdev denied due to instance type restriction. Please choose t2.micro. So perfect. And of course, You can create other variables. You can make this script a lot more flexible. But in our case, we're just going to keep it simple and keep the time down. So I'm going to go ahead and copy this, little Control C, head back over to the policy, going to click Edit, and I'm going to paste this in, and then I'm going to click Save Changes. Now, if you have any questions about a lot of this, and I'll include this in the course notes, Open Policy Agent has a great policy reference here. You can see how a lot of this is done. You can find a lot of great ways to ensure that all of your policies are as optimized as possible right from here. So let's head back over here. It looks like our policy is all good to go. Let's go ahead and run back over and let's trigger this sucker again. So I'm just going to click on retry and let's see what happens. All right, perfect. As you can see, the allow is going to work for us. It allows everything to pass. Now, because we have no changes, that might actually be a good reason why. Let's go make some changes and let's see what happens. All right, now we're finally going to see our policy in action. We're going to try to choose some instances that the policy is not going to be happy about, and we're going to see how it behaves. So let's get started. All right, the policy definitely passed last time because not only were the instances T2 micros, but we weren't making any changes, so it didn't care. It's only looking at what's going to happen after the change. So let's make some changes. So I'm going to bring my VS Code back up. Bring that over here, and let's make this thing mad. So we'll keep the compute module the same, but this guy Derek just wants to get a little crazy. He's going to try to launch a t2.large. So let's go ahead and save that. We'll run our git add, git commit -m. Derek is breaking the rules. Git push -u origin main, just like so. All right, let's head back over and choose this new deploying stack. And as always, pause and I'll see you shortly. Bam, perfect. Denied, just as we had expected. So we can take a look at the sample here if we'd like. And if I hit simulate, deny, module Derek dev, as you can see, also here denied by policy, module Derek dev, AWS instance dev node, denied due to instance type restriction. Please choose a T2 micro. So how about that? So if we take a look down at that one, which, oh, it's a long way down here. Just give me a second. We will find it. All right, if I take a look here somewhere around line 94, we can see that instance type looks a lot different than the one we saw before. So that is our problem. Now, if we head back in, obviously, I think you know exactly how this is going to turn out. If we head back to our VS Code and change this back to a T2 micro and save that. Let's go ahead and git add, git commit -m. Derek is playing by the rules now. Git push -u origin main. Head back over to our stacks. Click here once again. Here it comes. Once again, pause. I'll see you shortly. So of course this passed. Once again, no changes. So let's do something that's going to cause some changes and make sure that it's evaluating our plan. What I'm going to do is just select this whole module. Let's paste another one here and we will call this Susie dev, just like so. We're going to use the same compute module. Everything else will be the same. Linux is fine. Node name is going to be Susie. The key will be Susie key. And we're going to keep that t2.micro. So let's go ahead and make sure that everything looks good. So git add, git commit -m, added Susie, and git push -u origin main. All right, let's head back over and we're queued up. And pause the video. I will see you shortly. All right, so as you can see, the plan is allowing us to deploy. So feel free to go ahead and just discard this if you'd like. And then what we want to do is let's just go ahead and destroy this entire stack just to make sure that you're not eating into the free tier any more than you have to. So head back over to tasks, run that Terraform destroy auto approve task, and let it destroy, mark this lesson complete, and come on back to the next one so we can continue the course. Congratulations on finishing the course. Hopefully you have learned some useful skills and take those skills to build some really great products. Feel free to reach out to me if you have any questions whatsoever, and don't forget to Terraform apply yourself.